Hello everyone, welcome to the Digital Electronics class. In this presentation, we will see the working of SR flip-flop and we will also try to find out the truth table for SR flip-flop. From this figure, we can see that this part of the circuit is a SR latch using NAND gates, which we have already discussed in a previous lecture on SR flip-flop. We had also derived the truth table for the SR latch using NAND gates as shown in this table. From this table, we find that when the value of S star and R star are both equal to 0, then this is the not used case because we cannot determine the outputs Q and Q bar in this case. That is, we don't use this case when the value of the inputs S star and R star are both equal to 0. Similarly, when the values of S star and R star are 0, 1 and 1, 0, we get the outputs Q and Q bar as 1, 0 and 0, 1 respectively. Now when S star and R star are both equal to 1, then we are having the memory. For example, if it was 0, 1 in the previous case and if we give S star and R star as 1, then 0, 1 is being stored again. That is, we are having the memory. The memory means that whatever the previous value was there is being stored again when the value of the inputs S star and R star are equal to 1. Now we have modified this circuit by adding two NAND gates and we have also given a controlled input or clock here. This clock is basically a controlled input because we don't want the inputs S and R to change accidentally. That is, we only want these inputs to change when we want. So for that purpose, we have introduced a clock here. Now let us write the expression for S star and R star. We find that S star is the output of this NAND gate. So we can write S star as S and clock complement. And from De Morgan's theorem, this can be written as S complement plus clock complement. Similarly, R star is the output of this NAND gate. So we can write R star as R and clock complement, that will be equal to R complement plus clock complement from De Morgan's theorem. Now this is the SR flip-flop and the clock which is used here is edge triggered. We can represent this circuit diagram of the SR flip-flop by a symbol which is shown in this figure. We find that this is represented by a box and the entire circuit of this figure is inside this box. From this symbol of SR flip-flop, we find that it has three inputs S, R and clock and two outputs Q and Q bar, and this arrow here represents that this flip-flop is edge triggered. If this arrow was not there, then it means that it is level triggered. So this is the symbol for SR flip-flop. Now let us make the truth table for the SR flip-flop. We know that the truth table shows the relationship between the input and the output variables. So we have drawn a truth table of the SR flip-flop showing the inputs S, R and clock and the outputs Q and Q bar. Now we will find out the values of the input and the output variables. Let us consider the first case when the clock is low, then what happens to S star and R star. We find that when the clock is low, that is clock is 0, then 0 complement will be equal to 1. Similarly, here also 0 complement will be equal to 1. So the value of S star will be equal to 1 and R star will also be equal to 1. And from the truth table of the SR NAND latch, we find that when the value of S star and R star are 1, then we are getting the memory. That is, whatever the previous state was stored in the flip-flop or the latch, it will be there. So we can write this as memory. And we also find that whatever be the value of S complement and R complement, it is not going to change the value of S star and R star. So S and R don't care. So we represent S and R by X or cross when the value of clock is low. So we find that when the clock is low, then whatever be the input given to the two gates, it is not going to change our stored value, and the value of the output will be the same as the previous case. That is, we will have the memory as the output in this case. And for this purpose, we have introduced the clock. That is, the main purpose of the clock in our latches of flip-flop is to make it a controlled SR latch. Now, if the value of clock is 1, let us see what are the values of S star and R star. When the value of clock is 1, then 1 complement will be 0. So the value of S star and R star will be equal to S complement and R complement. That is, in this case we will get the value of S star as S complement and the value of R star will be equal to R complement, because the complement of 1 is 0. So the clock will have no effect on this S star and R star. So let us see what we are having in this case. Let us consider this case when the clock is high and S is 0 and R is 0. So the value of S star will be 1 and the value of R star will be 1, because 0 complement is 1, R complement is 1. So the value of S star will be 1 and value of R star will be 1. And from this truth table we find that when the value of S star and R star are both 1, we are having the memory, that is the previous output. So in this case also we will be having the previous output, that is, we are having the memory. And if the clock is high again and the value of S is 0 and the value of R is 1, then in this case we find that the value of S star will be 0 complement, that is 1, and R star will be equal to 1 complement, that is 0. So the value of S star is 1 and the value of R star is 0. And from the truth table of the SR NAND latch, we find that when the value of S star is 1 and R star is 0, then we are getting the outputs as 0, 1. So in this case, we will get the outputs as 0 and 1. Now let us see for the next case, that is when the clock is high, the value of S is 1 and the value of R is 0. So in this case, the value of S star will be 0 and the value of R star will be 1. Again, from the truth table of the SR NAND latch, we find that when the value of S star is 0 and the value of R star is 1, then we are getting the outputs as 1 and 0. So in this case, we will get the output as 1 and 0. Now let us check for the last case, that is when the value of clock is high and the value of S is 1 and the value of R is also 1. So in this case, the value of S star will be 0 and the value of R star will also be equal to 0. And when we check this from the truth table of the SR latch, we find that when the value of S star and R star are both equal to 0, this is the not used case. So in this case, when S and R are both equal to 1 and clock is also equal to 1, we will get the not used case. This is the contradictory case. So we find that this is the truth table of the SR flip-flop. This is how we can derive the truth table of the SR flip-flop. This is the symbol of SR flip-flop. So I hope that this truth table of SR flip-flop is clear to all of you. So that's all in this presentation. See you in the next presentation.